Okay, so I'm Oihana, I work at Tekniker, and I'm going to present our work titled Towards Data-Driven Metro Rail Maintenance Following the MLOps Paradigm. So in subway systems, especially in rails, the lubrication is vital, like to reduce wear, reduce also energy consumption and noise. This is especially important in curves because there the friction is higher. So this study uses the sensor data and machine learning to assess the impact of lubrication in subway curves, and the objective was to support a smarter maintenance decision. So in the subway, we had an installation with 6 accelerometers to read the vibration of the rail, and there was also a third-party lubrication system there. So here, the idea is that here the train comes from here. These triggers there are recording when a threshold is surpassed, and we record how the train goes through this section, a 30-second recording. And these lubricators put a certain amount of oil in the rail. So the idea is that when the train passes through here, the oil is spread across the rail. This third-party enterprise gave us this table to show how much oil they were putting in the rail. So the implementation of the MLOps from the machine learning part, we used Azure. Well, this is because we wanted to try a platform that can cover all the machine learning life cycle. So here, when a developer or every week, a pipeline is triggered, and this does the training of the models. We also do the data versioning, the model registry, and finally the models are deployed in an endpoint. So to do this, we use built-in tools, so this makes everything like easier to implement. And from the data acquisition part, like we said before, the accelerometer, when it's triggered, we get the recording of the accelerometers, so we get the vibration signals, and this also triggers a function to calculate the key performance indicators. When these indicators are saved, another trigger starts we call the models deployed in the REST APIs, and we get the results. So all these triggers have a small delay, so this is not real time, but we can say it's near real time because we obtain the results like 15 minutes after the train passes. And from the analysis part, first of all, we made a model to get the sensor health, because almost since the beginning, 2 accelerometers started failing. So yeah, we did a model to check the health or the status of the accelerometers. Then in the outliers, looking to the raw signals, we saw that some signals were had unusual patterns. Like this is the normal class that we expect in the vibrations, but we had some signals with an abnormally negative y-axis values. This weird signal too, that is a signal that's progressively decreasing, and this third one that it's a low amplitude signal. After further analysis, we saw that this third one was caused by the residual vibrations of the train. So we can say that this is like the tail of a normal signal. And from the main objective was also to see the lubrication status of the rail. So we made a XGBoost regression model, but as you can see here in the second part, when we use the last 25% of the data to make the predictions, the results are bad. So we can conclude that the vibrations alone are not enough to capture the lubrication conditions of the system, and that other factors play a role that we don't get the data from those parts. But we saw that when the lubricators, the sensors that were putting the oil in the rail, when they didn't put anything, that it's this gap, these two types of signals started appearing. So these signals can indicate that there are lubrication issues in the rail. Well, if you see here, also the lubricators weren't putting any oil, this fixed, and like normal signals started appearing, but the metro team reported us that there was increased noise in the rail, so they applied manual lubrication, and well, this like the normal signals started appearing when they did the intervention. So these two signals can give us like more insights of the rail. So as a conclusion, well, we did a MLOps pipeline based on to monitor the vibrations of the subway. So we did 3 models, one for the accelerometer's health, another for the signal classification, and the last one for the lubrication prediction. Like this third one could not reliably predict the dosage of the lubrication, but the outliers can give us like meaningful or more meaningful insights. And for the future work, we will, in the analytical part, we would like to add more signals, like for example microphones to capture acoustic signals or more data overall, and also develop an anomaly detection model, and one like better than the outliers model, because the outliers one was classified with like the signals that were manually labeled. So yeah, another model would be nice to do. And from the system part, now the metro team can see the results in a dashboard, but like it would be nice to implement real-time alerts and notifications, and also enable adaptive lubrication based on sensor data, because now the third-party sensors are like they put different amounts, but it's not based on data, on the data of the rail. So thank you for listening.